Hi and welcome to Vulkan from Zero to Hero.
In this section, we are going to draw our first triangle.
In this video, we are going to render triangle. Welcome back. This is the final video of this section. Before building command buffer, let's load our shader code from file. First, we need to specify the path to the shader files. Those files are in a folder named content, which is inside our running directory. First, load vertex shader code and then load fragment shader code. Now it's time to load our pipeline. We should define our dynamic states for our pipeline. It's better to choose viewport and Caesar for dynamic states. We also need to define our rasterization state. We are going to use the following parameters for our rasterization state. We don't need depth clamp enable. Also, we don't need rasterizer discard enable. The polygon mode is fill, determines how fragments are generated for geometry. The following modes are available. VK polygon mode fill, which fills the area of polygon with fragments. VK polygon mode line, that polygon edges are drawn as lines. And VK polygon mode point, which polygon vertices are drawn as points. Call mode determines the type of face calling we need to use. In our case, we've used backbeat. The front face variable specifies the vertex order for faces to be considered and can be clockwise or counterclockwise. We used counterclockwise for our framework. The rasterizer can alter the depth values by adding a constant value or biasing them based on a fragment's slope. Right now, we don't need to enable depth bias. The line width describes the thickness of lines in terms of number of fragments. Now for multi-sample state create info configures multisampling, which is one of the ways to perform anti-aliasing. And color blending attachment state contains the configuration per attached frame buffer. I change its member to have per multiplied alpha blend mode. Set blend state color to 0, 0, 0, and 0. And now it's time to call load function of pipeline. Just pass the parameters to this function. Okay, we need to draw a triangle. So in build command buffers function, add the following codes. Set viewport and viewport scissor. Bind pipeline. And call vk command draw function. We need to create a triangle with 3 vertices and 1 instance now. It's time to write our shader codes. Let's create 2 shaders. One for vertex and one for fragment in our content folder. Let's specify version of GLSL. We used 4.5, so add a preprocessor here. Then we need to specify GL underline per vertex, which will prepare vector 4 as an output of this vertex shader. In fact, vector 4 contains 4 floats. We wanted to draw a triangle. In this section, I will draw that triangle only by using shader. I mean the vertex shader stage doesn't have any input parameter. In the next section, we will learn how to use vertex assembly in order to draw a 3D model. Okay, let's define coordinates of triangle's vertices. The vertex shader calls for every vertices. Because in VK command draw, we set 3 for vertex count. So this vertex shader is called 3 times, and the built-in GL underline vertex index variable contains the index of the current vertex. We need to draw a 2D triangle, so we can pass 0 for Z parameter. After we write our code, we should compile it using GLSL validator. Go to the Vulkan SDK. In bin folder, we can find GLSL validator. Let's build our shader code with the following parameters. -v specifies source path to shader code, and -o specify the output path for generate SPRV file. Make sure the extension of source files are .vert and .frag, because the shader stage can be automatically determined from the file suffix. SPRV is a binary intermediate language for representing graphical shader stages and compute kernels for multiple Kernels APIs, including OpenCL, OpenGL, and Vulkan. The shader code is compiled and built successfully. Now go to the shader.frag and let's write our fragment code. In Fragment, we just set the output color of Fragment shader, which is yellow. Now build it again with GLSL validator. As you can see, both compiled shader binaries are built successfully. Let's build our project and let's debug our codes. As you can see, everything is fine, and after writing lots of codes, finally we can see this miraculous triangle. In the next video, we are going to learn how to enable Vulkan validation layer.